the next law, that is Faraday's second law. Correct. So Faraday's second law, we are talking of the series connection. Correct. We are talking of the cells which are connected in series. The cells which are connected in series. So what happens? The current flowing and the time taken is same for both the cells. Correct. Two cells, they are connected in series. So the current flowing and the time taken, it is same for both the cells. Right. Suppose the products formed, there are two cells. We are taking only one cell in the previous case. Now there are two cells, they are connected also. We will see the examples. So they are connected also. So 4 electrodes will be there. Correct. All the electrodes are connected. So suppose the products formed are A, B, C and D. Correct. So Faraday's second law, it tells us that weight of A ratio weight of B ratio weight of C ratio weight of D is equal to equivalent mass of A, equivalent mass of B, equivalent mass of C, equivalent mass of D. This is Faraday's second law. Correct. The cells, they are connected in series. So the current flowing and the time taken is same. Correct. And the weight of the products formed is equal to the equivalent mass of the products. Hope it is clear to you. So let's prove this, how this Faraday's law, the statement or the expression is written. So we'll prove this. So Faraday's law, yes. So the cell is connected in series here. I have taken two cells. They are connected in series, right? So here the outer cell, we will see the outer connection. It will act as cathode. This electrode will act as cathode, which is negative, right? So the other electrode will act as positive, which is anode. Now, in one cell, if this electrode is acting as cathode, this will be anode, right? And in this cell, if the first electrode is acting as plus, that means anode, this will be cathode. Correct? Okay. Now, the electrodes in this cell, it is made up of copper and the electrolyte filled is CuSO4 aqueous. The electrode made of silver in the first cell and the electrolyte is AgNO3 aqueous. Correct. Now the cell, it is connected in series, both the cells, they are connected in series. Correct. So the current flowing and the time taken to happen the reaction, that is same. Correct. Current flowing and the time taken is same. Let's check what are the products at cathode and anode in the first cell and in the second cell. So we'll talk of first cell. Okay. Product at anode. I'll explain you over here. We'll just write the product there. We are talking of the first cell, anode and cathode product I want. Correct. What is the electrolyte? Aqueous. So you have to follow electrochemical series. So products in first cell at anode, AgNO3, if it splits, what will happen? It will form Ag plus and nitrate ions. So nitrate ions will move towards anode, negative ions towards positive electrode. Ag is there, which is the electrode, and water is also present. Correct, because it is in the aqueous form. What about cathode? Cathode, same only we are talking in the first cell. So cathode, Ag electrode is already there, water is there, and Ag plus ions will move. Correct? Okay. Now for anode we have to take the lowest number, less number in the electrochemical series, correct. So water it is at 21, Ag it is at 19 and nitrate it is at 20. So lowest number it is for Ag. So the product at anode is Ag. I will write here Ag. What about cathode? Ag and Ag plus both. So number will be 19, water it will be 7. Reduction water you will take for cathode. Correct? Cathode means reduction water 7. So for cathode you have to take the bigger number in the electrochemical series. So 19 means Ag plus again silver. So the product at anode and cathode in the first cell it is silver. Both the same, silver. Correct. Now let's check in the second cell in which the electrolyte is copper sulfate, what products are formed at anode and cathode. Correct. So second cell at anode, water is already there in both, correct, because it is aqueous solution. At anode sulfate ions will move, negative to positive electrode, and copper electrode is present. Same way at cathode water is there, copper electrode is there and Cu2 plus ion is also present. Right. Now let's write the numbers. Check the electrochemical series and write the numbers. Copper 16 number, sulfate 23, water 21. Remember anode oxidation, so oxidation water it comes at 21 number. So for anode we take the lowest number, that is Cu, correct. So in the second cell at anode, copper is the product. Check for cathode product, water 7 number, that is reduction water we will take at cathode, copper that both 16, correct. So cathode we take the bigger number, 16 is the bigger number. So again at cathode the product is copper, right. So you can see here at anode and cathode in the first cell, Ag is the product, silver. In the second cell at anode and cathode, copper is the product formed, correct. What we are doing here, we are proving Faraday's second law, okay. Now let's apply the law. Let's apply the law here. So the law is like WAG upon WCU, correct. We wrote it in the ratio form and there were 4 cells, but here we are taking only 2 cells and the ratio I have written it as division form, which is equal to equivalent mass of Ag upon equivalent mass of Cu, correct. So W of Ag upon W of Cu is equal to, now you remember the equations what we have written, okay, previously in Faraday's first law. Few equations we derived, same we will write. After equivalent mass equation you have to check. So equivalent of Ag into I into T upon 96,500 whole divided by equivalent mass of copper into I into T upon 96,500. See children, this equation it is from Faraday's first law. We have done this equation after 2 small sums. We did for moles, what amount of element it is deposited at cathode anode, that 2 questions we have done, correct. After that we have found many formulas we were writing, right. So that formula I have written here. So both will get cancelled, IT 96,500 it will get cancelled. So finally you are getting this equation. What is this equation? It is Faraday's second law. Hence Faraday's second law is proved. Just for proving, we have taken one example and proved it. Hope it is clear to you. Correct? So here we finish with the electrolytic cells. Okay, electrolytic cells, where again I will repeat, if the electrolyte it is in the molten form, then directly you can write the products, what is formed at anode and what is formed at cathode. But if the electrolyte it is in the aqueous form, then you will use electrochemical series, right? So that was qualitative part. If coming to quantitative part, we have two laws, that is Faraday's first law and Faraday's second law. Correct? And we have proved the laws, all the equations of both the laws, very important, useful for the numericals. So next, in the next video, we will start with the galvanic cell. So thanks for watching, keep watching.